All right, everybody. We are going to do a video lesson, see how it goes. I will upload this video to YouTube, and then I'll send you a link. And then hopefully, if you have any questions, we'll be able to communicate that way. Either group me or actually group me is probably the way to go. And then we'll be meeting on day ones during our regular scheduled time, which would be 2:35. That'll be an opportunity for us to discuss whatever we need to discuss for that particular week. So I'm gonna, go slow as far as assigning homework. We're a little bit ahead of schedule, so we're okay. Probably gonna finish up teaching during this time off, and then we'll start reviewing for the AP exam. I'm going to keep going with the assumption that the AP exam will still be on, and I think it will be. That's not till May. So our first lesson is section 6.3, and we're going to find the general solutions for some differential equations, and we've done this already before, but I'll go through the notes just to remind you how to do these. So the first thing I'm going to do on this problem is kick the x squared minus 16 over to the other side. So this will become y prime equals 11x over the square root of x squared minus 16. Okay, so that's essentially the same as saying dy dx is equal to 11x over the square root of x squared minus 16. Then we're going to kick the dx over to the other side. So we'll have dy equals 11x over. Now we know eventually I need to rewrite this as x squared minus 16 to the 1/2. So let's just do it now. And the dx will go here. All right. And then we're going to do the antiderivative of both sides because we want the general solution, which is going to be y is equal to something instead of dy is equal to something. Okay, so this is going to be y. We know that the right side looks like we're going to have to do, we got division. We know that's bad. Usually our first option is u substitution. We do have parentheses, so let's go with u equals x squared minus 16. So that means du would be 2x dx. So dx would be equal to du over 2x. And that seems like that would be good because it's going to cancel our x's. And we're just going to have 1 over, well, we'll have a constant. So we'll have y is equal to the antiderivative. We'll have 11/2 out front because we got that 11 and that 2. X's will cancel. I'll be left with 1 over u to the 1/2 du. Okay. All right, now that's no good either, so we'll change this to u to the negative 1/2 du. It's better. And then we'll add 1. So that's going to be y equals 11/2, and that's going to be u to the 1/2 over 1/2 plus a constant. All right. Now this 1/2 right here, we're going to do the flip and a flop, and then that's essentially going to cancel that 2. So I would just be left with 11 u to the 1/2 plus a constant. And then I'm going to go y equals, and bring back the x, and that would have been, what was it, x squared minus 16 to the 1/2 plus c. All right, so that's my differential equation. No, sorry, that's my general solution of the differential equation. All right, so whenever you need to pause it, because I'm going to be doing a lot of erasing because I'm running out of room. Rewind it, take a look at it, whatever you need to do. Okay, so this next one, let's go 12y, and then I'm going to just go ahead and change that y prime to dy dx. I'm going to kick that over to the other side, so that becomes 7e to the x. Then kick the dx over to the other side, so I have 12y dy equals 7e to the x dx. Okay, so then we'll do antiderivative of both sides. And this one I would get 12y squared over 2, which would just be 6y squared. This one, it would just be 7e to the x plus a constant. So that's 7e to the x plus a constant equals 6y squared. We could leave it like that. It just says find the general solution. Doesn't say we need to solve for y. So we could leave it like that. If it did say to solve for y, we would divide by 6 and take the square root of both sides. All right. Okay, this one, we have an initial condition to, let's get everything on the correct side here. So I would have, let's say D capital T. So I got two T's here. So D capital T, I'm gonna kick everything over to the other side. So that'd be negative K times T minus 70 dt. All right. Then I'm going to divide both sides by T minus 70. So that'll give me D capital T over T minus 70 on this side. And then just negative K dt on this side. All right, so we're going to take the antiderivative of both sides. So this would be the natural log of the absolute value of T minus 70. And I would technically need to do U substitution, but the derivative of T minus 70 is 1, so it's not going to come into play. This side would be negative KT plus a constant. All right. So we need to, in this case, we are going to solve this for T. I guess it doesn't say that you have to, but with that initial condition, it's kind of implying that you need to solve this for T. So if I want to solve this for T, I'm going to do e to the on both sides. All right, so e to the ln T minus 70 is just going to be T minus 70. All right, so I'm going to go over here, hopefully be able to squeeze this in. So that's just T minus 70. I can drop the absolute value bars because I know it's going to be, in order for this to work, we had to take the natural log of a number that was positive. And then this side, we did this the other day when we were going through the proof of the formula of y. Remember, we had this formula, y equals c e to the kt. We derived that formula. So we're going to do kind of the same thing there. So we've got this e to the negative kt plus t down here. So I'm going to rewrite that as e to the negative kt times e to the c. That's the part that probably, I don't know if you'd figure out to do on your own. But now you got to know how to do that. Okay, and that's because if these bases are the same, we add the exponents. So this right here is the same as this down here. All right, but this is a more user-friendly version of it. So this would be t minus 70, and then e to the c is just another constant. So I'm going to call that C1, let's say. So it'd be C1 e to the negative kt. Okay, so now I'm going to plug in, because I need to figure out what that constant is, that C1, based on this initial condition. All right, find the particular solution that satisfies the initial condition. So capital T is like my y, and little t is like my x. So this would be 140 minus 70 equals C1 e to the negative k times t, little t, which is 0. All right, so that's 70. E to the 0 is 1, so it's telling me that C1 is 70, so that constant is 70. So my solution then would be t minus 70 equals C1. I'm using this equation right here. C1, which we found to be 70, e to the negative kt. All right, so that's my general solution. Or actually, in this case, it's a particular solution, not a general solution, because we don't have a plus c. We actually found out what c was. So that's the difference between a general solution and a particular solution. All right. Okay, so I think this is the last one. So we want to find the equation of the graph that passes through the point and has the given slope. Okay, so that's a kind of a convoluted way of saying we got to find the equation again, the general solution. And if we're given a specific point, we're probably going to go ahead and find out what the constant is, and then we're going to find a particular solution that passes through that particular point. All right, so we got y prime here, so I'm going to change that to dy dx is equal to 2y over 3x. Then I'm going to bring the 3 and the y over to the left, and I'm going to bring the dx over to the right. It doesn't really matter where the constants go, but I just feel better if it's not a fraction. All right, so we would have 3 dy, and I need the y over here, so that's got to go on the bottom, equals 2 over x dx. All right, just take a second to look at that, make sure you understand where everything came from. Just doing some algebra. Oops. Okay, so we're going to do the antiderivative of both sides. The antiderivative here would be 3 times 1 over y, which is not right. That's what we had before. It's 3 times the natural log of the absolute value of y equals 2 times the natural log of the absolute value of x plus a constant. All right, now, this is the weird part. So it is a constant, but I'm going to say I want the natural log of that constant in order to make my algebra easier here. And that's a totally legit move. All right, so this would become the natural log of the absolute value of y, but we can assume that these are positive numbers, otherwise I couldn't be doing this. So this is going to become y cubed. This is going to become the natural log of x squared plus the natural log of c. All right, now the whole reason I did that is so I could rewrite this like this. The natural log of y cubed equals the natural log of c, which is a constant. And this is addition, so I can rewrite this as the natural log of c x squared. Okay, now just a reminder, so if I took this and I rewrote it using the properties of the logarithms, which says that if you have multiplication, you can change it to addition, I would end up with this. So this is a contraction. So when we were doing logs earlier, we expanded and we contracted. In this case, we're contracting. Now, the whole purpose of doing that is to make this part easier. All right, so I'm going to come up here and I'm going to have the natural log of y cubed equals the natural log of cx squared. And I'm going to do e to the, and so that's going to simplify to y cubed. And this is going to simplify to cx squared. Okay, so we need to find out the c in this case. So we're going to use that point. X is 8 and y is 2. So we're going to have 2 cubed equals c times 8 squared. So that's 8 equals 64c. So c would be equal to 1/8. All right, so then my equation then would be, so I'm going to use this equation right here. So that would be y cubed equals 1/8 x squared. All right, and again, you could simplify that if you wanted to solve for y, but they're not asking me to, so I'm not going to do it. Okay, so that was our first set of notes online. We'll see how it goes. And, you know, I'm going to make things due on certain dates, but you got to do these a little chunk at a time. And that way it's not so overwhelming when they're due. And then also ask questions as you go along. And, you know, you can do that as always via GroupMe. That's the best way to contact me. And, you know, we can converse back and forth. And then again, every day one at 2:35, but we're only going to have 2 day ones before spring break, so that won't be a lot of time. I may set up some more times if there's more questions. We can set up another time, maybe in the evening, to talk. All right, I'll talk to you guys soon.